All right, let's look at the homework 4.3, problem number 3. All right, so we want to find the first derivative and second derivative. All right, let's do that. All right, first derivative. So this is just a power rule, right? So we have derivative of x cubed is 3x squared. Derivative of negative 3x squared would be negative 6x. And derivative of negative 8x would be negative 8. And derivative of 3 is 0. All right, so that's the first derivative. And the second derivative, derivative of 3x squared would be 6x. And derivative of negative 6x would be negative 6. And derivative of negative 8 is 0. So we have that. All right, so let's type it in. So we have 3x squared minus 6x minus 8. And then we have 6x minus 6. All right, so let's check the answer. All right, it came back and looks like we got the first derivative and the second derivative correctly. All right, so we want to find a c such that the second derivative equal to 0 is set it equal to 0. So if you set this equal to 0, you can see that x is going to be 1 or c equals 1. So I'm going to just go ahead and put 1. All right, let's check the answer. All right, so we got the c value correctly, and then we want to look at the concave up and concave down, and also inflection point. All right, so we're going to look at the second. We know that here we're going to do a number line, here, and the c value we just found was so it was 1. All right, then we just have to look at the sign of f double prime. So f double prime. All right, so try anything less than 1. So I'm going to try x equals 0. All right, 0 minus 6 is negative. So we have a negative second derivative there. And anything bigger than 1, so I'll try 2. Right, 6 times 2 minus 6 is going to be positive. So we have a positive there. Right, so we know that the original function is going to be concave down before 1 and then concave up after 1. Right, so type it in. Concave up is going to be, actually I forgot which one is which. Concave up after 1, right? So it's going to be start from 1 and positive infinity, right? Infinity, right? So we have that. And then before 1, so it's going to be negative infinity to 1, right? So we have that. And the inflection point is going to be at 1. So I'm going to put the x coordinate as 1. And then if you plug 1 back in, maybe we can do this in our head. 1 cubed minus 3, so negative 2. Minus 8 is negative 10. And plus 3, negative 5. So it's going to be negative 5. So you just plug 1 into the original function to get negative 5. All right, let's check the answer. All right, it came back and looks like we messed this up. So it's, let's see, inflection point at 1. And let's see, if you plug in 1 here, 1 minus 3, negative 2, negative 8, so negative 10. And negative 7, sorry, I messed that up again. All right, let's check the answer. All right, this time we got the inflection point correctly, right? And, interval of concave up and the concave down got them correctly as well. All right, that's it. I hope that this was clear.